Well, it's about one of these challenges that children face when they get to be about 5 years old and transition from developing knowledge in a common sense, spontaneous manner to going to school where they have to start grappling with formal subjects and building formal skills like learning to read and mathematics in particular. And for many children, this transition is relatively smooth and successful, but for many children it's not. It's really challenging, and that's particularly true of children living in poverty whose parents had no schooling themselves and who therefore aren't growing up developing common sense knowledge in an environment where schooling is available. So what we tried to do in the study is design a program for children like that, children in India living in the poorest sections where they now will be attending school because school is compulsory now, but where their parents did not, and see if we can develop activities that they can play in relatively informal preschool classrooms in groups that will give them the kind of preparation they're going to need to succeed in school the following year when it begins.
So I've been working on primary education on and off for about 15 to 20 years in developing countries, in India, in Kenya in particular. And one thing that we have consistently found is that key problems that children face when they reach the middle of primary schools is that the curriculum is such that teachers are compelled to teach to the top of the classrooms because the curriculums are very demanding. And they are not particularly interested in teaching any of the children who have reached grade 2 or grade 3 or grade 4 without the knowledge that places them at the top of the pack. And as a result, what happens very quickly in primary school is kids get lost, they stop paying attention, they get promoted from class to class, and they reach the end of primary school with essentially very little knowledge. About half of children who have completed primary school are unable to read a very simple paragraph that they should master at the end of grade 1. So a lot of my work has been to show that this is something that can be solved by teaching at the right level, by teaching the kids that people have in front of them. And this is actually tremendously effective. We've been working with education NGOs in India and elsewhere to do that. But it faces a very frustrating political opposition from educationists who write down curricula in these countries, and as a result, in a sense, from teachers who are getting their cues from the management, who are not interested in dumbing down the curriculum, who are not interested in doing what it takes once the kids are in front of them. So although I'm not giving up this fight, I'm also started to think about, well, if we could take the poorest kids and instead of sending them to school with a slight gap because they haven't been to preschool or they haven't been to very good preschools or their parents are not able to help them out in their schoolwork, why couldn't we try to use the best of cognitive science available and bring them to school with a slight advantage, with a slight leg up? So this is when I got in touch with Speke, who first came into my life in the form of big pictures in the New York Times, which had done a profile of hers. At that time, I had a child. My first child was a few weeks old. And I became, to the great amusement of all of my colleagues, very, very interested in preschool and early childhood development, stuff like that. So I read this article quite closely. And then I got to meet her once more at a lecture that I was giving, and at this point I thought, okay, this is a clear signal. I need to get this professor to help me out and think about how to bring the best of what they have thought about for the last 50 years or so and bring it to improve the curriculum that these kids are exposed to in pre-primary school.
So let me make a confession. In my life, it never occurred to me that I would ever end up collaborating with an economist, or for that matter, doing an experiment that actually could eventually make a difference in the real world. But Esther Duflo, of whom I'd been a fan for a very long time, challenged me with an opportunity that I couldn't turn down. She pointed out relatively tactfully that although I had spent a lot of time trying to figure out what children know at different times, what knowledge develops before what other knowledge, what conditions we can use in laboratory experiments to move children's knowledge along, the real thing that we want to understand is how knowledge grows in people in the real world. And for young children, that means grows spontaneously in homes and in preschool classrooms. And the opportunity that she provided was to look at this question, bringing to bear all the rigor that we use for our research in the laboratory, yet focused on a situation in the real world where we could do a real experiment, a randomized control experiment, to evaluate the impact of interventions informed by basic research in cognitive science on young children's development.
So this curriculum was targeting children between the ages of 4 and 5 years. And we designed 2 different sets of games for kids to play. The main intervention was a set of math games where kids were encouraged to exercise their intuitive abilities in number and geometry. So in particular, skills that allow them to estimate the relative number of dots, large numbers of dots, and compare those numbers to sort cards. So there'd be a large number of red dots on one side of a card, a large number of blue dots on the other side of a card, and kids would have to sort the card by the color of the more numerous dot array. So this was a game that was meant to be played by small groups of children in pairs or slightly larger groups, and it was supposed to be fun, fast-paced, and social. So kids could interact over these cards and have maybe little competitions or cooperative play. Other games that we created were also aiming to tap into numerical skills. For example, small number operations, one-to-one correspondence operations. So you spin a spinner, it shows 1, 2, or 3 dots, and then you pick a number of cards, the number of cards indicated by the number of dots that you spin. Those cards have shapes on them. You move forward on a board that has shapes by the number of shapes that you drew on your cards. So really lining up things one-to-one correspondences and doing small number addition. We complemented those numerical games with geometric games. So map reading was one game that kids played where they had a small scale visual form on a card and they had to relate the geometric information on the card to a larger scale environment on the floor. The kids loved this one. They got to move around, interact with one another, talk about the shapes on the cards, the shapes in the environment. There was another game in which kids looked at a bunch of shapes, 6 shapes on a card, and they had to pick out the one that didn't belong with the rest based on some geometric property, like angle information or length information or parallelism. This is another one that encouraged teamwork and was a lot of fun. Kids could interact with one another, agree or disagree about which card didn't belong, and teachers could provide feedback. So these were all the kinds of skills that emerge really early in human development, sensitivity to intuitive number and geometry, that the games were targeting in a social context that were meant to be fun and encourage sort of desire to play together and desire to engage in these kinds of skills. We also made a group of games for the active control condition. So the target treatment was these math games, but we also made games that had the same rules and structure as the math games, but targeted different content. These games targeted content in the social domain. So instead of exercising kids' intuitive skills for number and geometry, they exercised kids' intuitive skills in the social domain. For example, their ability to follow another individual's gaze or read their emotional expression. So these skills are arguably just as important early in preschool education to allow kids to interact with one another, interact with their teachers, and so they were truthfully presented to children and teachers as potentially beneficial for their early learning.
So what we did is we followed up the kids who were exposed to these different interventions right after the end of the intervention, and then some months later, and then another full year later. So immediately after the end of the intervention, we found that children who had played the math games had significant improvements in their intuitive concepts of mathematics, both geometry and number comparisons. They also showed some improvement even in symbolic skills, such as recognizing numbers and things like that. The children who had been part of the games which have the same rules but engage social skills instead showed improvement in social skills but not in mathematics. So that could tell us that this was really about the content of the games, not the fact that there is an adult playing games with them with these rules. Several months later, what we found is that the gain in intuitive mathematics were very persistent. However, all the symbolic games had gone. So it's not that the kids had regressed, all the kids had progressed. They had now joined schools, so both in the treatment group and in the control groups, they had learned numbers, additions, multiplications, whatever, something, but they had learned that equally in the treatment and the comparison schools.
We learned what in a sense is we learned there's one thing that's quite similar, I think, about field experiments and laboratory research, although many things are different. The great blessing of doing experiments is you learn when you were wrong. You learn when your ideas were too limited. You learn when there were important factors that you failed to take account of. And I think in this experiment, we learned a couple of things that were strongly positive. And one thing that really provided us with a guide, I think, for future work, where I think basic thinking in cognitive science maybe was not broad enough. The positive things that we learned are, first of all, the research that we do in rarefied laboratories, mostly with children living in well-educated families and so forth, actually can uncover basic processes that operate all over the world. The kinds of activities that we developed for children in India are just the kinds of activities that excite children in Cambridge, Massachusetts, right? We really were able to take the fruits of our experience with research in the lab and develop games that were effective at engaging kids, at getting them to learn things, and in fact remained effective a full year later. After games were taken away, children still were showing benefits from the games that we had developed for them. We also learned that much of our descriptive work in cognitive science, studying development, generalizes to populations very different from the populations in which that work has primarily focused, and to assessments made under conditions that are very different from the conditions that we use in the laboratory. So we see the same abilities, the same limits, the same relationships between one ability and another when we study the numerical and geometrical reasoning of young children in India that we see when we study children in the West. So in all of these ways, I think what these studies tell us is that there's a bright future for field research that builds on basic laboratory studies in cognitive science and tests them out in the real world, all over the world. But the negative thing that we learned, I think the most important thing that we learned, is that the work that we've done in the laboratory is not sufficient to establish what actually causes knowledge to grow in the mind of a child over time spans of years in the environments in which children live and learn.
So there are many next steps that we are taking, and we are quite already somewhat advanced in the process of the next steps. The first, of course, and very important from my point of view, especially given my original motivation in creating a curriculum that was going to give a heads up to the poorest kids in Delhi, is to work on a set of games that will actually have a durable impact on mathematics. And there what we used is, what we are building off is our impression, our hypothesis that one of the things that might have gone wrong is that the school system itself is not really relying on knowledge of mathematics. Learning mathematics in primary school in Delhi, it's closer to learning poetry, because they are learning, to sing 1 times 1, 1, 1 times 2, 2. And in a sense, the greater understanding of the concepts wouldn't be particularly useful. This is how you learn mathematics. So what we are trying to do is to include in the games themselves some element of bridging between the intuitive knowledge of mathematics and the formal knowledge that they will be actually exposed to. And that can be done in the preschool games. So we've done a series of experiments where that is done explicitly. That can be done also by trying to have programs that will be implemented in primary schools in the very early years of primary school, so in parallel with their learning of mathematics, which will serve also to say, hey, by the way, this kind of poems that you're learning that seems to make no sense at all, this is what they'll be used for in playing games and in playing games that have mathematical contents. So that's one set of things. Another set of things we're trying to work on is to take these learnings to the US. Now that we've developed and tested these like exciting games that people can play with, we are testing them. We have done a first set of pilot in Framingham in a Head Start center. And then moving 3 steps ahead, in a sense, is once we are happy with the curriculum we do have, is to try and find ways that it becomes a more mainstream part of the preschool curriculum. And although one can't be too optimistic ever, I feel that this is a program where we might have more luck than in my effort to have teachers teach at the right level in primary school, because unlike primary school, in India anyway, there is not too much views of what should be taught. And preschools, it's viewed mainly as a way to have the children hang out somewhere socially, and which is useful as well. And proposing content actually for teachers to have in preschools might be appreciated instead of resented. So I'm hoping that the political economy of this will work easier, or in an easier way once it comes time to scale up.